Okay, so without further ado, we'll dive deep into this. Thank you all for joining us a couple of hours before lunch, so I still have you very energized, I hope, from the morning coffee. My name is Liran. I do a bunch of work around web security, node security. I research a lot. I find vulnerabilities and dependencies in code, lately in coding agents, which is what I want to talk to you today about. Do this part of my work as a developer advocate at Sneak, as indeed was said before. But happy to collaborate and talk about any other open source related aspect of it. So catch me online or just after this talk. I look at you and I see a lot of young people. So I don't know if you understand the reference, but we'll do I hope some of you are. But we start with a journey of like, how did we get here to the age of AI? So it started with basically writing code. You had no option when you were at home a few decades ago. Basically, you either write code or you write code. Nothing else to do, really. We moved ahead, and the journey ahead was like we write code or we copy code. So there was a thing called Stack Overflow, like a long time ago, that was fulfilling our needs when we didn't know how to do something or just stuck on a question. So this was a popular website once upon a time. And then we had this idea of like not just writing code, not just copying code over copy paste and stuff. We were going into this journey of installing code through like a very programmatic manner, right? Like that's the dependency. So we were doing npm installs and stuff like that. The lucky guys doing C++ are welcoming this, looking at this with much envy because this is now coming to that world. So congrats to them. And then we kind of like moved over, right? Like a few years back, I remember 2021, back in the day, feels. GitHub Copilot kind of was the raging, AI kind of magic, the way to write code. It used to be called like a tab to complete or tab to code. You'd have this ghost text where GitHub Copilot on the IDE on VS Code naturally when it just debuted was providing you not just IntelliSense autocomplete, but like full function code. And that was a very magical moment. But we passed through that and right on to this stage where we are now, vibe coding, jam coding, contextual engineering, coding agents, background agents, cloud agents, whatever you want to call them. Basically, we're at this point today. And now you just have to prompt. So what are the dangers that are lurking in terms of security? So one aspect of vibe coding, and this is one critical way of looking at what this means, might be that you're creating debt. Right? We're just prompting away, not necessarily looking at what is the code that gets generated. We keep saying keep or allow, or God forbid, just like YOLO mode, like allow all and let the agent run, which is, it's nice, and some of you are looking at this and thinking, yeah, this is tech debt that's piling up. But when I look at this tweet, I'm like, that's not just tech debt, that's security debt, okay? That there's a lot of vulnerable code and dependencies and just really pragmatic approaches that do not get spilled into what should be your production-grade application because you just accept random generated code. So some of the vibe coding risk, I'll just show you like a bunch, maybe a quick couple to talk through it. But here's an example where someone was like vibe coding an app, which is cool and fun, but not really what you want to do for production, because if your code has the wait list on the front end, then bad things like this happen. Or maybe someone is saying, Cursor just stole $100 from me. Not really, but what happened here is like there was no implementation on the actual subscribe button, so potentially this person lost revenue. There is a lot of gap and mismatch between expectation of how you expect code to be generated, the quality of it, that you expect, that you've been grown to expect, than what you actually get at the end of the day, even though something looks functional. So when you look back at all of the journey that we went through, and you kind of like ask, what's the common denominator here, right? That has to be code. Right? Code is the common denominator here. That's what we see all the time. Apparently, attackers see the same thing. And not too long ago, this was the case with the code that you were writing. Attackers try to understand what kind of vulnerabilities might exist in your code, and so they try to attack insecure code that you wrote. And at the same time, they could target insecure coding dependencies that you use through CVEs and vulnerabilities that are made public, and they can now exploit and run payloads against you. So how does that look when we transition to vibe coding? Well, honestly, not that much different from that perspective specifically, because now it's simply the fact of who generates the code. If it's not you, then it's an agent, right? It's a coding agent, it's an LLM. So the LLM generates this, and basically similar to what you were generating before, it's just not the human, but it could still be vulnerable code. So from an attacker perspective, not much has changed. And so we're going to look at this type of security concerns. I'm going to group them into this thing called LLM to code. And I'm going to do this because we're going to talk today about two generic problems. There are many problems around AI security, but we'll only have time to talk about two of them. One is using LLM to code. And the other part of this equation to the side is basically LLM in code. And that is how you, as developers, use LLMs in a way of an AI SDK or something else to just power your AI apps through the fact that you integrate with an LLM. So basically what's happening here, the model becomes sort of like a layer, an intermediary layer that is between the user input to whatever the application does, and it's just a layer that gets input, output, and that's it. But there's issues there. So we'll talk through both of them. I'll group them into these things called AI-powered apps, which is the LLM that you integrate in your code, to AI-assisted coding, which is the coding agent and gets many names. And honestly, this moves so fast, so it's hard to stick to one name, but we'll use this generic one. And I'm going to show two examples of potential security issues. One is going to be prompt injection, but I'll show you specific areas of how prompt injection is not just exfiltrating data, but actually impacting business logic and dropping to like more vulnerabilities inside the code itself. And on the AI-assisted part, which we'll start with, we'll talk about vulnerable code that the LLM generates. So let's dive into it and kind of like ask with, what do you think about this, right? Like, will AI-assisted coding generate vulnerable code? Because I can't not notice your faces, and maybe you're saying no, but like, OpenAI just released GPT 5.1 or 5.2, and it's a new model, and it's trained, and it's great code. So let's take a look at what history taught us. History, yes. This is an academic research paper from February 2025, history. It found that if you look at JavaScript specifically, about 1 in 25%, so 1 in 4, of JavaScript code is every line gets found to be vulnerable to about 40 different types of CVEs. That's different types of vulnerabilities, right? So if you try to understand what that means, how many vulnerabilities can you count by name? Code injection, patch reversal, XSS, authentication, broken authentication. We can count more, but can you count 40 of them? That's the amount of different types of vulnerabilities, different types of variety of vulnerabilities that were found as part of this. By the way, this research was also comparing between JavaScript and Python. So if you're a Python dev as well, there's some insights here. And I bet you're thinking about it, right? Liran, just prompt the LLM to also fix the problems. Like it's a prompt away. Genius. They did the same thing. The researchers did the same approach. And they were like, hey, we did the same thing. This is the result. Basically, if you tell the model, here are the vulnerabilities that you found, please fix them, it would only be able to fix 20% of them. So if the entire pie here is your application, the code that you push to production, only 20% of the vulnerabilities might be in some models that you use, maybe you don't even use those models, will be fixed without extra static application security testing help to enrich and guide the model what to actually do. If you are using GitHub Copilot, they will formally say, this is from the docs, that whatever you use with Copilot is basically you own the responsibility around security. That's not part that they guarantee or promise for you, so that's on you, all of us. And here's another research from also like history, so long ago. This is in March 2025. Sorry for the Python code. I know it's a bit obscene here in a Node.js conference, but bear with me here. So to the left, this research was trying to say, well, let's benchmark how well do coding agents are able to cope with fixing vulnerabilities. On the left is a perfectly working code, but it has a vulnerability in it. There's a path traversal issue there. It's a very simple code. On the right, the model, in this case DeepSeek Coder V2, was told to fix it. So the code on the right is fixed, but I'm not sure it's actually working. So good luck. There's many examples of this. You can just deep dive into all of this research and see what people are actually benchmarking. So let's see some real examples beyond benchmarks. Let's start with AI-assisted coding. And what I'm going to do here is I recorded a video not so long ago trying to create a post-API route upload, and I'll show you how it looks like. So open ChatGPT. Not everyone has coding agents, like government and banking and very highly regulated systems, so sometimes you have to go off, do this from your other system, and maybe copy the code or do something else. But let's say you say, implement a post endpoint in Fastify, create a route to upload files. Now, maybe I'm a developer who hasn't dealt much with uploading files, so I have no idea, it needs some dependencies. There's an aspect here about multi-part file uploads. Maybe I have no idea what this is or how should it be handled. So I will prompt ChatGPT, I will take this, and the next thing I will do, of course, is copy-paste it, right? So I'll open my IDE here. All I need to do is basically create a new file, copy the code from ChatGPT, post it here, save it. And actually, this code is super functional. It just works, literally that. But I do have my IDE plugin here for Sneak, which actually says there's a path traversal vulnerability here hiding. So if I weren't very security conscious, aware to really locate that there is a hidden pattern that actually is insecure, and I would just accept the code, it is functionally working, but it is also vulnerable at the same time to a path traversal attack that is easy to execute against this server. So unless I had something to help add this guardrail, I wouldn't know this. Here's another example. I simply, because you're probably thinking about it, just tell it to create secure code, right? So here's another example. I just told it, yeah, just create secure code. It is safe, and so on and so on. A different example, read YAML. Here is the code. I hope you can, by this point, understand that there is a vulnerability here. Hopefully, you also found it. There is a reference from the other one. But if you haven't, and you have some kind of security tool that helps you understand and scan the code in a very deterministic manner without hallucination, without any kind of generic non-deterministic aspect to it, then you would find it. So again, prompting, create safe and secure code, not always the best thing. Let's try something else. Let's try a different approach. Let's try this. When Copilot went out, got published, and I remember seeing that developers wanting the code to actually that gets generated to be very in line with the standards of the code that actually is within the application itself, which makes sense, right? If you use semicolons, you want to follow semicolons. If you use spaces, you want to use spaces and not tabs, all of those kind of things. But what if your existing code base is not the perfect code? What if it has existing vulnerabilities in it? So here's a Java code base. Again, sorry for the obscenity. This isn't JavaScript. But if I have a class that uses SQL injection with concatenation in not a very secure manner, somewhere in the code, even just an example aside, it is very much possible that Cursor and Copilot or something else will read a code and try to follow the same semantics, the same coding conventions that our team uses. And if they do, when they go and suggest coding text in something like a tab to complete, you see the ghost text from Copilot, or a coding agent does this entirely itself, it might go ahead and amplify the existing vulnerable surface, right? It will create more code similar to what you've done. And this is a very contrived example, but there are much more complicated examples that you may not even notice that would happen because it just amplifies your existing coding style, your existing types of dependency resolution or whatever practices you actually apply. So another aspect of when you use LLMs to generate code, you have to be very conscious to those kind of issues. Now, Claude 3.7 sounds like decades ago, like so long ago, right? But when it went out, we did an interesting experiment. So on the Sneak YouTube channel, what we have is over the past, I think, couple of years, we've been doing this experiment where we use the exact same prompt, which says, hey, please create an app, and make it super secure, and so on. And we use the same prompt across different coding agents, different models, different AI apps, coding agents too, to see what do they actually generate. So here's an example. That's my buddy Brian. He's using, and this is the day after Claude 3.7 hit, right? So it just released. We used extended thinking. Brian passed the code. It says, create a simple web to-do application, note-taking application. There's CRUD pointers there to create, update, delete notes. And it tells the model, right, take it super seriously, make it secure. If not, I'll be fired. Try to simply stress the model to understand how important it is to generate secure code. And we use this across different apps. So there's a history of what was the case 2 years ago and what it is today. This is Claude 3.7, not really that long ago. But when this went out, the code it generated was actually pretty good. So if you go through the code line by line, and by the way, all of this and all the prior experiments, you can see them in the different directories, is open source. You can go to the GitHub and find it. But when we looked at what happened with Claude 0.37, and when you look at it from a security kind of expert perspective to it, you can understand what's going on. So there's a request size limitation, XSS escaping, no SQL payloads middleware there to stop this, rate limiting, a bunch of guardrails you would think really make sense to add to your code. There's even schema validation, right? This is a note-taking app. There's users involved. They take notes. There's safety, again, in a different middleware against NoSQL injection. There's a second middleware on NoSQL injection. Pretty good. There's database level schema validation, so to a point where there's a regex that actually checks that the email is secure. There's a regex that checks that the email is secure. There's a regex that checks that the email is secure and validated, but it's not really a good regex. It's actually a bad regex. So regexes have this thing where they could be written in a way that's not very performant. So you might have seen, if you use NPM, I assume, you might have seen that you've been found to have a dependency that's vulnerable to something called regular expression denial of service, RDoS. And what it looks like is kind of like this. This is the exact match of what the regex that was just generated by Claude 3.7 to validate the email address. And if you pass this type of input to it, it would actually create a denial of service on the running node server. So that regex is bad. It's bad to a point where there's a good couple of minutes that takes time to process that regex with this payload. And that's Claude 3.7. And you kind of have to ask yourself, would you recognize that insecure pattern of a regex, that flawed pattern of writing regular expressions? Because if you wouldn't have, and you just accept LLM-generated code, this is a very deep one, too. So you kind of have to think about it and let it kind of stew in your brain a bit to which other kind of issues are you actually allowing without paying too much attention. Let's move on to the other side of things, okay? We'll stop with the AI-assisted coding. There's a few examples that I try to give you to understand what are the concerns there and talk about AI-powered applications. So this goes into what the OWASP top 10, that's a different kind of list and it's sort of like a standards, that says LLMs over-reliance. Let's start with an example and maybe a research back to 2015 where Google announced something called adversarial attacks over imagery. Okay, so this is a famous back experiment that was taking a picture. Obviously, we recognize it as a panda, okay? And they've basically layered another picture on it, another layer of pixels that flip the right neurons. That's a disturbance pattern that we don't really see, but when LLMs see both of them now layered one over the other, they now recognize it as a different thing, as a gibbon, not as a panda. Okay, so that's prompt injection, but in a visual way. Okay, so we're going to see that an example of this. I'm going to show you a prompt injection that actually changes the business logic. So I went on Twitter one day. I think this was posting this, and I was showing these charts. I want to build an app that it's basically a credit score, like a financial system that I build. So someone uploads their financial statement, and they want to get back a credit score analysis, like the banker that want to get this back and understands if credit is allowed to be given to the user or not. So the way that we would do it is you upload a file, your PDF of a financial statement, export of a PDF from like a banking site, and what would you use to analyze and run credit score analysis? LLMs, right? Makes sense. So I share this, and this is part of like a vulnerable scenario. And I had someone saying like, this is like almost identical to what I've built, some other time. Which, I hope they're aware of the issues going on here. What issues? Let's see. These are the issues. This is the banking app. So here's the actual demo. I am now the banker. I'm operating the system. I want to add more balance to this customer, but I have this AI credit score analysis that I need to get PDF from them to upload, analyze, and see if I get yes, no. So the way I do it, there's obviously a credit score endpoint. What does it do? It, of course, checks that the user is, admin, all of those kind of things. It gets the file. It extracts the text from the PDF. Makes sense. I want to extract the text, and I want to push it over something that's called eval credit score system, which is, again, driven by LLMs, as we said. So you just prompt the LLM, you give it all the text of the PDF, and your helpful AI assistant, go over this, reply only with excellent, fair, or poor. Assess if someone gets, high expenses but low income, of course, going to be poor, right? So you use all of those things, and you even use distinct system prompts and user models, and it looks perfect. Like, it actually works. So let me show you how it works. I'll upload a file. This is Alice Cooper. She uploads this. Her salary is only $480, and expenses at about $5K. So obviously, we kind of know what's going to happen. They're probably going to get a very bad or poor credit score analysis, which is what happened, and the LLM indeed showed this. But what happened if Alice uploads a different kind of PDF? To the naked eye, it looks the same. It's the same amount of income, the same amount of outcome. It's the exact same PDF. So Alice uploads this one, and now when the banker opens it, they get an excellent score from the LLM. Why is this happening? Well, prompt injection. Let's see. Now, in the code, I will show you how I extract the data out of it. And when I extract the data, you can see that towards the end, you can see all the income and input and salaries, but you can see that I've also added a specific payload, a prompt injection that steers the model to say that this customer actually has like an exemption from the manager that allows them to get an excellent score, right? And so we don't see it with our naked eye when we parse the PDF, but the machine gets that data because all I had to do was edit the PDF, add this text as white on white background, and while we don't see it, the machine gets it. So here's a clever way of how to pass those systems, and really simple. All of you can do it tomorrow and play around with this. Here's another example, right? Another reference of why prompt injection might be problematic. How it kind of like jumps, not from changing business logic, but creating an SQL injection. So it's actually, like the prompt injection will actually exploit code that you have that might be insecure. Some would say potentially more dangerous. So the same banking app, and it has a chat application, right? A chatbot. So in the code, I will show you this in a second. What I do is I log all the data that the LLM produces. Okay? I don't log all the data that the user enters, all the chat questions, because that might be a breach of privacy and stuff like that, PII, whatever. And so I will show you, I have like this chat audit logs. It's now empty. And I have users. There's a user table, but there's a users, plural, table as well. And what I want to do is just chat with this bot. And again, all I'm doing is saving everything the LLM gives me. Okay? So everything the LLM gives me is supposed to be secure. Like I trust LLM as input and output, not exactly the user input and output. So if I run this, and you will understand something more, I think, substantial here. is actually prompt inject a specific payload to try and do an SQL injection to drop the user's table. And I tried for the first time, and the user's table is still there, so it didn't work. But LLMs are not deterministic. It means that I maybe just it didn't really work one time, and the second time it also didn't work. But that's OK. I can just keep trying. On the third attempt, I will try, and now there's no user's table. So the way that the LLM created its response to the drop table, like I apologize, blah, 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 all of that there, the way that it actually responded to me, and all of that got logged into the code is where I was able to put my payload into the system. And why is that happening? Because if you look at the response, like this is the actual response itself, you see that the drop tables users will get written in a way that if I go and put that into my code, the way that I insert it is I would now create an SQL injection. Because the problem is not really the LLM, it's basically not the user either. You can't really stop users from trying different stuff and being crazy. But we have a problem with the code itself. The code is not written in a secure way. The way that the db.exe call runs and the way that it just concatenates user input with the actual query in a bad way creates an SQL injection, right? But the fallacy here is, if you think about it from a developer perspective, we don't give the same amount of trust to users as we do to LLMs. Like for us, the output of an LLM is something potentially secure and smart, right? And intelligent AI. But not always. They can be steered in a different way. So if you have this fallacy where you trust the LLM's output and push that into the application itself as part of the data warehouse, ETLs, whatever you do with the data afterwards, and it flows into insecure code practices that you already have, then you also have another attack surface that can be abused against you. So it's not prompt injection to cause the business to do something else, like we've seen with the case of the sentiment analysis. It's not prompt injection to do, to get Amazon or something else to get you a different price or, lock the car or whatever. This is something that actually flows into your code and exploits it. So there are many, many other type of vulnerabilities. We just covered a few of them in different aspects. I hope I was able to give you some of this actual real-world examples of how you exploit and weaponize LLMs against you. There are more, so definitely go off and read something like, just Google OS Top 10 and read some of those best practices. Thank you very much. I hope you generate tokens, but secure them as well. It was a pleasure.